Um, Hello everyone, good evening. So here we shall solve some more JEE Mains previous year questions on the chapter properties of ma- matter. So any doubts if you have, please write that in the comments, and please install our Sapience education application where we shall upload some important questions which shall be obviously helpful for your exam. And in any other chapter of physics, any doubts if you have, or if you have more difficulty in that, then please mention the name of that chapter also in the comments so that we can give more priority on it and solve more and more questions on that chapter. So here it is told that an elastic spring under tension of 3 Newton has a length A. Its length is B under tension 2 Newton. So there is an elastic spring. It is an elastic spring. So it is when the tension force that is applied. So suppose one end is fixed. So here the force is 3 Newton, then the length is A, which is actually the actual length plus the extension. Extension is suppose x1. So we know that force is equal to the spring constant K into x. So therefore x is the extension. So here I will say here this 3 Newton that is equal to K into x1. And similarly, when it is under the tension 2 Newton, if F is 2 Newton, then the extension x1, x2 I can say uh, that is B. Then the length 3a minus 2b will be how much that we have to find out. I can say that x1 will be obviously a minus L, which is L is the natural length of the spring, suppose. And so x2 is equal to, but then actually x2 is the extension, x2 will be b minus L obviously. The length is b, x2 is b minus L. So therefore I will say that 3 equals to k into a minus L. 2 Newton that will be equal to k into p minus L. Therefore we can say value of the when the length a minus 2b, the tension will be how much? Means the force F1 that is how much that we have to find out. Now therefore from here we can say k equal to 3 by a minus L. Therefore we can say Q will be equal to 3 by a minus L into b minus L. Means that a minus L by b minus L that is equal to 3 by 2. Equal to 3 by 2. Now therefore, if we cross multiply it, then we will get 2a minus 2l that will be equal to 3b minus 3l. So therefore, we can say that this will be 3l minus 2l that will be equal to 3b minus 2l. That means L is equal to 3b minus 2. So the length is the natural length is 3b minus 2 only. So therefore, it is told when the length is same as the natural. Okay, this is 3b minus 2 is the natural length. Now therefore, when the length L dash that is L plus x, the extension x, that is, let's say x3, that is equal to 3a minus 2b, then the tension force will be how much? Then F1 will be how much, that we have to find out. So therefore, L, that is 3a minus 2a plus x3, that is equal to 3a minus 2b. Therefore, x3, that would be equal to 3a minus 2b, 2a minus 2b minus 3b plus 2a. So this will be 5a minus 5b. This 5 into a minus b. This is the extension. So now, therefore, the force that is required, F1, that will be k into 5 into a minus b equal to k into x3. Now, if we subtract these two, then we will get 3 is equal to Ka minus Kl and 2 is equal to Kb minus Kl. Now, if we subtract these two, then we get 1 is equal to K into A minus B, and these two will get cancelled. So K into A minus B, that is equal to 1 only. So therefore, we can say that is K into x3, that is 5 into A minus B. K into 5 into A minus B. So this is 5 into K A minus B. Now K A minus B is equal to 1. So this is 5 into 1, that is 5 Newton. So 5 Newton will be the value of the tension in this case. So 5 is the answer. Then here it is told one end of a metal wire is fixed to a ceiling and load of 2 kg hangs from the other end. One end of a metal wire is fixed to a ceiling, a load that is 2 kg M that is hanging from the other end. Then a similar wire is attached to the bottom of the load. Similar wire is attached to the bottom of the load, and another load of 1 kg comes from the lower wire. Similar wire is attached to the bottom of the load, and another load of 1 kg comes from this lower wire. The ratio of the longitudinal strain of the upper wire to that of the lower wire will be. The ratio of this longitudinal strain of the upper wire to that of the lower wire ratio of the longitudinal strain. Okay. So the longitudinal strain of the upper wire to the longitudinal strain of the lower where strain is delta L by L, change in length by original length. So here we can say that the stress that is equal to the tension per unit area of cross section. So area of cross section of each wire is same. Young's modulus is also same, and G is also same. So we can say the tension will not be the same. So we know that stress equal to Young's modulus into strain. Now we can assume the wire to be massless. So therefore here the weight that is coming, that is 10 Newton, is mg. Here the weight that is coming, that is 2g plus g, that is 3g, that is 30. And this is 20 Newton, 20 plus 10. So here the tension force is T1, suppose, and here it is T2. Therefore T1 will be equal to mg, that is 30, and T2 that will be equal to 10. So therefore the stress on the first wire, that will be 30 by area of cross section, and for the second wire the stress will be 10 by, you have to find epsilon 1 by epsilon 2, means the ratio of the longitudinal strain of the upper wire to that of the lower wire. So the stress in the lower wire, the stress in the lower wire, that is 10 by A. No, therefore we can say sigma epsilon 1, that is sigma 1 by y, and epsilon 2, which is the strain in the second, so strain in the lower wire, that is the stress in the second wire by the Young's modulus. So therefore epsilon 1 by epsilon 2, that will be equal to sigma 1 by sigma 2, that will be 30 by 10 is 3, is equal to 3. So option, so 3 is the answer. Then here it is told a plane is in level flight at constant speed. Plane is in a level flight at a constant speed. Each of its two wings, has an area of 40 meters square. So both wings will have 80 meters square. So if the speed of the air the speed of the air is 180 kilometer per hour over the lower wing surface. So in the lower wing surface, the speed is 180 kilometer per hour, and over the upper wing surface, we have 250 kilometer per hour over the upper wing surface. The mass of the plane is. So we can say that we have to apply the Bernoulli's equation, that P plus half rho V square plus rho GH, that is equal to constant. So now the height of the two wings from the ground level, that will be same only. So I can say this rho GH will be also constant. Since the height is same for both the wings, so the pressure will be different on the upper surface and the lower surface, since the velocity of the air with respect to the plane, that is not same for the uh, lower wing surface and the upper wing surface. So I can say that E1 minus P2 is equal to half rho to V2 square minus V1 square. Therefore, E1 minus P2, that is equal to half. Okay. So now we have to find, so the upward force, upward, that is the dynamic lift, the dynamic lift force, that should be equal and opposite to the weight of the plane. Then only it can have a level flight. So this force, the lift force, that is equal to P1 minus P2 into A, where A is the area of the wings, and that will be equal to half into rho into 2 square minus V1 square into A, where A is the area of the two wings, and that should be equal to mg. So the mass of the plane, mass we have to find out. So therefore m, that will be equal to rho A by 2g into V2 square minus V1 square. So this, if we apply, then we will get the mass of the plane. So where rho is the density of the air, which is 1 kg per meter cube, and A is the area of the two wings, which is 80 meters square, divided by 2g. G is 10, and V2 square, it is 252 kilometer per hour. So we have to convert into meter per second. So this is 252 is into 7 by 18. No, 252 into 5 by 18. Since when in kilometer uh, per hour, we can convert into meter per second by multiplying it with 5 by 18. So here we will get 9 to the 18, 9 to the 18, and then 72, 9, 8 to the 72, and 2 14 is 28, and then 14 5 is 70. 14 5 is 70. 180 into 5 by 18, and 10. So this is equal to 50. Should be equal to 70 square minus 50 square, equal to 80 by 20 into 70 minus 50, that is 20, into 70 plus 50, that is 120. 20 and 20 will get cancelled. 12 it's 96, 9,600. Okay. Uh, so 9,600 kg is the mass of the plane. So 9,600 is the answer. Here it is told two blocks of mass 2 kg and 4 kg are connected by a metal wire going over a smooth pulley as shown in figure. The radius of the wire is 4 into 10 power minus 5 meter. The Young's modulus of the metal is 2 into 10 power 11 Newton per meter square. And so here, the longitudinal strain developed in the wire is longitudinal strain, that is delta L by N, which is epsilon, that we have to find out, and that will be equal to obviously stress by Young's modulus. Stress that will be equal to the tension per unit area into Y. So this value we have to find out. And if that is equal to 1 by alpha pi, then alpha value we have to find out. Now here we can see that here this will be 40 Newton force, and here it is 20 Newton force, and here is tension, here is tension. So you can say 40 minus T, that is equal to 4A, and T minus 20, that is equal to 2A. Now we have to cancel out this acceleration, or simply if we add them, then T will get cancelled, then we'll get 20 is equal to 6A. So A will be equal to 2, 3, 6, 2, 10, so 20. So acceleration is 10 by 3. So therefore T will be equal to 20 plus 2A, 2, so 20 by 3. So that is 23 is 60, so 80 by 3 Newton. The tension force is 80 by 3 Newton. Now, therefore, the strain that will be tension force 80 by 3 by A, that is pi r square. R is 4 into 10 power minus 5 whole square into Y. Y is the Young's modulus is 2 into 10 power 11. So this will be 80 by 3 pi into 4 for the 16. 16 into 2 into 10 power minus 10 into 10 power 11, that is 10. 0, 0 will cancel. Then 8 to the 16. So this is equal to 1 by 3 is 12 pi, which is equal to 1 alpha pi. So therefore, the value of alpha, that is equal to 12. 12 is the answer. And here it is told the depth below the surface of the sea to which a rubber ball can be taken, so as to decrease its volume by 0.02 percentage. So we know that delta V by V, which is the uh, the volumetric strain, that is equal to the pressure divided by the bulk modulus. So it means the excess pressure by the bulk modulus. So therefore, now delta V by V is the volumetric strain, that is equal to, it is told it decreases by 0.02%. So it means the decrease, the change in the volume, that will be, so minus delta V by P, so it is minus of 0.02 by 100, which is minus 2 into 10 power minus 4. So the bulk modulus is 9 to 10 power 8, and the density of sea water. So therefore, the change in the pressure, that is equal to rho GH. Therefore, delta V by V. So here, delta V by V, which is the change in the volume, decrease in the volume, that is 2 into minus 2 into 10 power minus 4, and this is equal to minus rho GH divided by B. So therefore, we have to find the depth below the surface. So H we have to find. H is the depth below the surface of the sea. So minus minus will cancel. So H will be equal to 2 into 10 power minus 4 into um, would be bulk modulus of rubber, that is 9 to 10 power 8, divided by rho into G. Rho is the density of sea water, that is 10 power 3, and the value of G, that is 10. Then this will be 10 power 4, then this will get cancelled. So 2 nines are 18. So the depth below the surface of the sea is 18 meters, at which the decrease in the volume will be 0.02%. So 18 is the answer. Then here it is told a big drop is formed by coalescing 1,000 small identical drops of water. 1,000 identical drops of water are coalesced to form a big drop. So if E1 be the total surface energy of 1,000 small drops of water, E1 is the total surface energy. The total surface energy of 1,000 small drops of water, which will be 1,000 into 4 pi r square into S, where S is the surface tension. Since we know that surface energy is surface tension into surface area. Surface energy is surface tension into surface area. You can say 1,000 into 4 pi r square into S. And it is told E2 be the surface energy of the single big drop. So E2 will be equal to 4 pi capital R square into S. So E1 is this. Then E1 is to E2 is x is to 1, where x is how much. So now here the mass should be conserved. Now, since their density is same, so we can say the total volume of the system will be conserved. So therefore, now the volume that is equal to of these 1,000 identical drops is 1,000 into 4 by 3 pi r cubed. Okay. So 1,000 into 4 pi into small r square that is equal to 4 by 3 pi, okay, 4 by 3 pi r cube, and that is equal to 4 by 3 pi capital R cube. 4 by 3 pi 4 by 3 pi cancel. So r cube equal to 1,000 into small r cube. So therefore r will be equal to 10 r. So the radius of the big drop is 10 times the radius of each small droplet. So therefore E1 is to E2 that we have to find. E1 is to E2, that is 1,000 into 1,000 into 4 pi r square into s. 1,000 into 4 pi r square into s divided by s into 4 pi capital R square. Now capital R square will be 100 R square. Since R equal to 10 R. S will cancel, 4 by 4 pi will cancel, R square also will cancel, 100 and this 100 will cancel. So it is equal to 10. So E1 is to E2, that will be equal to 10 is to 1. So X, value of X will be equal to 10. So then each of the three blocks PQ and R shown in figure has a mass of 3 kg. Each of the wires A and B, each of the three blocks PQ and R shown in figure has a mass of 3 kg. This block also has a mass of 3 kg. Each of the wires A and B has cross-sectional area A, that is 0.005 centimeter square, and the Young's modulus, that is 2 into 10 power 11 Newton per meter square. Then neglecting friction, the longitudinal strain on where B is. The longitudinal strain on where B is epsilon B that we have to find, which is the stress or the uh, tension force in the wire B divided by area of cross section, which is nothing but the stress. So stress by Young's modulus. So that will be the strain. So this is value we have to find out. So now therefore each of the wires has cross-section area. Now the tension in the wire B that we'll find. So here, this is suppose all are having mass 3 kg only. So this will be 30 since by mg, g is 10, 30 Newton. Here tension force. This is also the tension force. Here also tension force. Then this will be the tension T1. Suppose T1 is the tension force on the wire B, on the wire A. This is also T1. So I can say 30 minus T, that is equal to 3A. Then 30 minus T, that is equal to 3A. And here we can say that T, so there is no friction. So T minus T1, that is equal to 3A. All will have the same acceleration of obviously. And T1 that is equal to 3A. Now if we add these two, then we'll get T equal to 6A. And so 30 will be equal to 9A. So A will be equal to 30 by 9. So A is equal to 30 by 9. So 3 10 the 33, 3 the 9. So A will be equal to 10 by 3. So therefore, T that is equal to 6A. So 6 into 10 by 3. So 3 to the 6. So that is 20 Newton. So 20 Newton is the tension force in the wire B, I can say. So therefore, the strain on the wire B, that will be equal to 20 Newton by area of cross section, which is 0.05 centimeters square. So this is 0.005 into 10 power minus 4 meters square. It means it is 5 into 10 power minus 7 meters square. 5 into 10 power minus 7 meters square into 1 by y. Y is 2 into 10 power 11. So this value we have to find out. So 2 5s are 10. And this is 10 power minus 7 to 10 power 11, that is 10 power 4, and minus 7, that is 4. So this is 2 into 10 power minus 4. So then neglecting friction, the longitudinal strain on the wire B, that will be 2 into 10 power minus 4. So 2 is the answer. And here it is told two metallic wires P and Q have same volume and are made up of same material also. So P and Q, they are okay. P and Q, they are two wires, two wires A and B. They are having the same volume. So volume of P, that is same as volume of Q, and they are made up of the same material also. So their density is also same. Density of rho P and rho Q are same. Let's say that is rho only. Uh, if their areas of cross section are in the ratio 4:1, so it means here the area of P, that is equal to 4A, I can say, and the area of Q, that is A, suppose. And force F1 is applied to P. When force F1 is applied to P, then the extension produced is delta L. The force which is required to produce, so how much force is required to produce the same extension in Q, that is F2. So when F2 is applied, then also the extension is written in the okay. So when F2 is applied, the same extension is formed, that is delta L, and whose value we have to find out. So now F1 by F2, that value we have to find out. Now, so here we can say F1 by A, that is 4A, that is equal to the stress, that is equal to Young's modulus into. So since their material is same, so the Young's modulus will be also same for both P and Q. So this stress that is equal to Young's modulus into strain, that is delta L by L. L by L. Now their material is same, so it means the density is also same. Density is same. The volume is also same. So if the volume is same, but here the area is 4A, then here the length will be L by 4, and here the length will be A. Means the length of P, that will be L by 4, and length of Q, that will be L. Since here it is told the volume should be same. So Y will so it will be F1 by 4A, which is the strain, the stress in the where P, stress in the where P, that is equal to Young's modulus into strain in the where P, that is delta L by L by 4. So therefore F1 would be equal to Y into 4 into delta L by L to 4A. So this will be F1 will be equal to 16 into Y A delta L by L. F2 that will be so F2 by A, I can say that will be equal to Y into delta L. The extension is same only. Delta L by L. It's F2 that is equal to Y A into delta L by L. So therefore from here I can say this is equal to F2 only. So F1 is equal to 16 F2. Therefore F1 by F2 that will be equal to 16. So 16 is the answer. And here it is told in a test experiment on a model aeroplane in wind tunnel. The flow speeds on the upper and lower surfaces of the wings. So uh, here what is happening? On the upper surface, the velocity that is V2, that is 70 meter per second, and on the lower surface V1, that is 65 meter per second. Okay. Is where the wind is blowing with respect to the uh, aeroplane. And if the area, area is 2 meters square, wing area, then the lift of the wing will be how much? So then the lift of the wing. So the lift F, that is equal to the change, the difference in the pressure into area. Now difference in the pressure, that will be equal to half rho into V2 square minus V1 square. Here we are using so here we are using according to the Bernoulli's principle. Bernoulli's principle that P plus half rho V square plus rho GH is equal to constant. So now the density of the air, that is given as 1.2 kg per meter cube. So therefore the force or the lift on the wing, that is equal to delta P into area. So that is area A into half rho into V2 square minus V1 square. So therefore the lift, that is equal to half into rho, that is density, that is 1.2, and area, that is 2, into V2 square is 70 square minus 65 square. Then this will be into rho into A, 70 square minus 65 square. So this is 2 will cancel. So 1.2 into is 70 plus 65 into 70 minus 65. So this will be equal to 1.2 into 5 into 135. So 12 5 is 60. So 6 into 135. 135 into 6. So 6 5 to 30. 6 5 30. 3 6 18. That is 21. 6 1 6. That is 8. So this will be equal to 810 Newton. So 810 is the answer. Yeah, so here it is told that the reading of pressure meter attached to a with a closed pipe is 4.5 into 10 power 4 Newton per meter square. Opening the valve, water starts flowing. The reading of the pressure meter falls to 2 into 10 power 4 Newton per meter square. The velocity of water is found to be root V meter per second. The value of V is. Now, it is a closed pipe. Now, pressure meter is attached to the closed pipe. So the pressure was 4.5 initially when the uh, pipe was closed, means the velocity of the water flow was 0. Then the pressure was P1, which is 4.5 into 10 power 4 Newton per meter square. And on opening the valve, the velocity of the water flow, water will start to flow, V2 will be root V meter per second, and the pressure will be P2, that is 2 into 10 power 4 Newton per meter square. Then the value of V. So we know that the change in the pressure, that is equal to half into rho into P V2 square minus V1 square. Here we are applying the Bernoulli's principle. Bernoulli's principle. So now this delta P, that is 4.5 into 10 power 4 minus 2 into 10 power 4, that is equal to half into rho. Rho is the density of water, which is 10 power 3 kg per meter cube, into V2 square minus V1 square, which is root V whole square minus 0 square. So now we have to find. Now from here we can see that 10 power 4 I can take as common, and then this would be 10 power 4 into 4.5 minus 2, so 2.5, that is equal to 0.5 half to 10 power 3 into V. So 10 power 3, then this will cancel, 10 will come. So 0.5 point, I can remove 5, so 25. So V will be equal to 50. So the value of V is 50. Then it is told the average depth of an ocean, base depth is 4,000 meter, and the bulk modulus of the water is, the bulk modulus of the water is 2 into 10 power 9 Newton per meter square. Then fractional compression of water at the bottom of the ocean is, fractional compression of the water at the bottom of the ocean is, so delta V by V, that is equal to delta P by V. So delta P, that is rho GH divided by B. Delta V by B, that is rho, that is the density, that is 1000, 10 power 3 into G, that is 10 into H. It's 4,000, 4 into 10 power 3 by B. Bulk modulus of the water, 2 into 10 power 9. So this is given as, this is should be equal to alpha into 10 power minus 2, then alpha value you have to find. So it means this will be to the 4, so 2 into 10 power 3 plus 3 6 plus 1 7 minus 9, that is minus 2, which is alpha into 10 power minus 2, so alpha will be equal to 2. So the value of alpha is 2. Then here it is told wire of length L and radius R is clamped rigidly at one end. When the other end of the wire is pulled by a force F, force small f, its length increases by L. Wire is there, is having length L, and radius is R. It is clamped rigidly at one end, and the other end of the wire is being pulled by a force small f. The length increases by small l. And another wire of same material and having length 2l and radius 2r is pulled by a force 2F, then the increase in the length L dash will be how much we have to find. So here the Young's modulus will be the same. Since it is told the material of the wire is same, so you can say y will be equal to F by A, which is pi r square by delta L, that is L by L. Since y is FL by pi r square L. And here also y will be equal to 2F into length, that is 2L by pi into 2R whole square into L dash. And that should be equal to, and that should be also equal to this Young's modulus, which is FL by pi r square L. So now here we can see this will be 4FL by, this will be 2 to the 4 pi r square into L dash, that is capital L, that is FL by pi r square into L. So 4 will cancel, and FL will cancel, pi r square will cancel. So from here we can see that this L will be equal to L dash. So the same increase in length we will have. So the answer is option C. Then here it is told given below are two statements. One is labeled as assertion and the other is labeled as reason R. The assertion A is spherical body is there having radius 5 into 10, 5 plus or minus 0.1 millimeter, having a particular density that is falling through a liquid in constant density. Density is constant. The percentage error, so the density is constant. The percentage error in the calculation of its terminal velocity is 4%. So the that terminal velocity that is given as 2r square rho minus sigma into g by 9 eta. Now therefore we can see that the terminal velocity is directly proportional to r square. So therefore the percentage error in terminal velocity that is equal to twice of the percentage error in the radius. So therefore here the percentage error in the radius, that would be 0.1 by 5 into 100%. So this will be 5 2s are 10. So this is 2 into 2, that is 4%. So assertion is true. Then the reason is the terminal velocity of the spherical body falling through the liquid is inversely proportional to its radius, which is false. Since the terminal velocity is directly proportional to the square of the radius. So A is true, R is false. So option B is the correct answer. Then here it is told the figure shows a liquid of given density flowing steadily in horizontal tube of varying cross section. Cross sectional areas at A is 1.5 centimeter square and B is 25 millimeter square. If the speed of the liquid at B is 60 centimeter per second, PA minus PB is given. PA and PB are liquid pressures at A and B points. This percentage sign will not be there. And the density of water is 1000 kilogram per meter cube, and A and B are on the axis of the tube. So first we have to apply equation of continuity, which is A1 V1 V1 that is equal to A2 V2. Now A1 V1 that is equal to A2 V2. So area at the cross section A is 1.5 centimeter square into the velocity at the point A that we need to find out, and area at the point B, that is 25 millimeter square. So I can say 1 millimeter square, that is 10 power minus 2 centimeter square. 10 power minus 2, it means it is 0.25 centimeter square into V2, that is 60 centimeter per second, the velocity at the point B. So now centimeter square will cancel. So V1 that will be equal to 0.25 into 60 by 1.5. This much centimeter per second. So point will be cancelled. Point will come here, and then 15 4 the 60, 4 5 the 20. So this is 10 centimeter per second V1. V1 plus half rho V1 square, that is equal to V2 plus half rho V2 square. Here we are using the Bernoulli's principle, since here the height at the point A and B will be same. So rho GH part will get cancelled. It means PA minus PB, it is same as P1 minus P2. That will be equal to half rho into V2 square minus V1 square. It means it is half. Yeah. So therefore, P1 minus P2, that will be equal to half into the density, which is 1000 10 power 3 into V2 square. V2 the velocity at B, that is V2, it is 60 centimeter per second, or I can say it is 0.6 meter per second, and V1 that is 10 centimeter per second, or I can say 0.1 meter per second. So this will be 0.6 square minus 0.1 square. So P1 minus P2, that will be equal to 1000 by 2, that is 1 by 2 into 1000 into 0.6 plus 1 plus 0.1 into 0.6, so 0.6 plus 0.1 into 0.6 minus 0.1. So this is 0.5, this is 0.7. This will be P1 minus P2, that is 500 into 0.7 into 0.5. So this is 250 into 0.7, which is 1 minus P2, that is 25 into 7. 7 5 is 35, 7 15, 175 Pascal. So option B is the correct answer. When it is told under isothermal condition, the pressure of the gas is given by P is equal to A V power minus 3, where A is a constant and V is the volume of the gas. The bulk modulus at constant temperature is. So when temperature is constant, it means I will say PV will the pressure into volume that is constant, and bulk modulus, as you know, that is minus dp by dv by v. So here we can differentiate both sides, then we will get pdv plus vdp that is equal to 0. So it means pdv that is equal to minus vdp, means minus vdp by dv minus vdp by dv that is equal to t. It means that the bulk modulus that will be same as the pressure only, P. Here actually we can say dp that will be equal to minus 3 a into v power minus 4 into dv, which means dp by dv is equal to minus 3a v power minus 4 and is by v power 4. Now into v into minus v, if I do on both sides, then we will get minus v dp by dv that is equal to 3a v power minus 3. 3a v power minus 3, which is equal to 3p. So here it is not told that PV equal to constant, so this one we can't use. So since it is told P equal to a v power minus 3, so this only we have to use. So 3p, so option C is the correct answer. And here it is told 8 equal drops of water are falling through air. 8 equal drops are falling through air with a steady speed v of the steady speed, suppose u, that is 10 centimeter per second. If the drops coalesce, the new velocity is. If the drops will coalesce, then the radius will change. Now the terminal velocity that is given as 2r square into rho minus sigma g by 9 eta. Now all these values will remain constant. Rho, sigma, g, eta is constant. So the terminal velocity is directly proportional to square of the radius. Now suppose initially the radius was r, and then if the drops coalesce to form a big drop, then its new radius will be how much? New radius will be, so the volume we can take that it is same, since if we apply conservation of mass, then since the density is same, so the volume also will be same. So 4 by 3 pi r cube, that will be equal to 4 by 3 pi r cube into 8, since 8 drops will coalesce to form a single drop. So the volume of the single drop should be same as the volume of the 8 drops. So 4 by 3 by 4 by 3 pi will cancel, so r will be equal to 2r. R will be equal to 2r. So now therefore the initial terminal velocity was something, suppose k into r square, since the remaining part is a constant. So the final terminal velocity will be k into r square, which is equal to k into 2r whole square, which is 4 into kr square. So it means the final terminal velocity that is equal to 4 times of the initial terminal velocity. So it is 4 in, now initial terminal velocity was 10 centimeter per second. So the final one will be 4 into 10, so 40 centimeter per second. So option A is the correct answer. It is told Young's moduli of the material of wares A and B are in the ratio 1:4, while its area of cross sections are in the ratio 1:3. And if the same amount of load is applied to both the wares, the amount of elongations produced in the wares A and B will be in the ratio. Now the Young's moduli of the materials of the wares are in the ratio 1:4. So YA is to YB, that is equal to 1:4, while its area of cross sections are in the ratio 1:3. The same amount of load is applied to both the wires, then the amount of elongations produced in the wires A and B will be in the ratio of. It is told the lengths of the wires A and B are the same. The same amount of load is applied to both the wires. The amount of elongations produced in the wires A and B will be in the ratio of. Okay. So it means that one of the wires there it is having area of cross section A, and the other wire is having area of cross section suppose 3A, and its Young's modulus is Y, its Young's modulus is 4Y. Then if the same amount of load is applied to both the wires, means the force applied is the same. The amount of elongations produced will be in the ratio. So means delta L in the where A by delta L in the where B, that will be the ratio how much that we have find. So now you know that force that is equal to YA by L into delta L. So or I can say delta L is equal to FL by AY. And here it is told assume lengths of wires A and B are same, length is same. So therefore delta L A by delta L B, it will be equal to F. The force is also same, so FL by area AY by this is where A and where B. Okay. By FL by 3A into 4Y. This will be FL by AY into 3 4 that 12 AY by FL. The FL will cancel, A by A will cancel, so that is equal to 12 is to 1. 12 by 1 means 12 is to 1, so option C is the correct answer. Then here it is told given below are two statements. Statement 1 is pressure in a reservoir of water is same at all points at the same level of water. So pressure in a reservoir of water, pressure in a reservoir of water is same at all points at the same level of water. Pressure will be same at all points at the same level of water. So that will be same. So that is true only since why at the same level the pressure will be same only. The pressure applied to enclosed water is transmitted in all directions equally. That is also true. So both statement 1 and 2 are true. So option B is the correct answer. The second statement is actually the statement of the Pascal's law, which tells that if a pressure difference is created at any point in an enclosed fluid, then the pressure will be transmitted in all directions equally. So that only has been told that the pressure applied to a closed water when enclosed water is transmitted in all directions equally. So it's true. So here it is told hydraulic automobile lift is designed to lift vehicles of mass 5,000 kg. A hydraulic automobile lift is designed to lift vehicles of mass 5,000 kg. A hydraulic automobile lift is uh, designed to lift vehicles of mass 5,000 kg. The area of cross section of the cylinder carrying the load is 250 centimeters square. Maximum pressure the smaller uh, piston has to bear is. So the maximum pressure that the smaller piston has to bear is same as the pressure that is created by the load only, which is equal to force by area. This force will be equal to mg. Force is mg by a. So m is 5,000 into g, that is 10 by area, that is 250 centimeters square. So 250 into 10 power minus 4 meters square. Since 1 centimeter square is 10 power minus 4 meters square. So 250 will cancel, 25 to the 50, so 2000, so 200 into 10 power 4 meters square, which is equal to 2 into 10 power 6. So this much it will be Newton per meter square, or 2 into 10 power 6 Pascal. 2 into 10 power 6 Pascal, which is option D is the correct answer. So hope all of you understood the solutions of all these questions. Still any doubts that you have, please write that in the comments. We shall obviously clarify them, and please install our Sapience education application also. So thank you everyone. Bye. Okay, so here it is told an air bubble of volume 1 centimeter cube rises from the bottom of a lake. It rises from the bottom of a lake. It rises from the bottom of a lake, that is a lake, and which is 40-meter deep, 40-meter deep to the surface. It rises to the surface at a temperature of 12 degree Celsius. Temperature is 12 degree Celsius. And the atmospheric pressure is 10 power 5 Pascal. Then the density of the water, that is 1000 kg per meter cube, and G is 10 meter per second square. There is no difference of the temperature of water at the depth of 40 meter and on the surface. So there is no difference of the temperature of water at the depth of 40 meter and on the surface. The volume of the air bubble when it reaches the surface will be. Now, the pressure difference P minus the pressure inside the air bubble minus the pressure outside, that is equal to 4T by R. The T is the surface tension. Now the pressure inside minus the pressure outside when it is at the depth below the uh, lake, that will be P inside minus P naught plus rho GH, where H is the depth and rho is the density of water, and that is equal to 4T by R. And when it will be on the surface, then it will be P inside minus P naught, that is equal to 4T by R dash. But here obviously the difference will be lesser. So 4T by R value will be less, so R will be higher. When it will be on the surface, the radius will decrease. It's why the difference in the pressure of the inside and the outside is higher. Now this value is 1 centimeter. Uh, okay, volume is 4 by 3 pi r cube. By 3 pi r cube, that is 1 centimeter cube. I can say that r cube, that will be equal to 3 by 4 pi centimeter cube. So r is the cube root of this. So therefore, you can say that 4t by Yes. So the temperature remains constant. So here we have to use the concept that is pressure into volume that is constant. So here we have to use the concept that is pressure into volume is constant. Since the temperature is remaining unchanged, we will do that pressure P1 V1 that is equal to P2 V2. So the pressure at the depth that is P naught plus rho GH and V1 that is given 1 centimeter cube and P2 that is P naught into V2. So this V2 I have to find out. Right. So here it is E naught that is atmospheric pressure that is 10 power 5 plus rho GH rho is 10 power 3 into G that is 10 into H that is 40 to 1 centimeter cube that is equal to 10 power uh, 5 Pascal into V2. Now this will be from here 10 power 5 I can take as common 10 power 5 into 1 plus 4 to 1 centimeter cube that is equal to 10 power 5 into V2. 10 power 5 will get cancelled, so V2 will be equal to 5 centimeter cube. So the volume of the air bubble when it reaches the surface it will be 5 centimeter. So here we are assuming when we are writing P1 V1 equal to P2 V2, we are assuming that the air is considered to be an ideal gas. So here it is told the aluminum rod when Young's modulus Y undergoes elastic strain of 0.04%. The energy per unit volume stored in the rod in SI units. So we know that the energy stored that is equal to half kx square. Now k is equal to ya by l and x is delta l whole square. So this we can write half into y al into delta l by l whole square. So therefore energy per unit volume is al. So that is half into Young's modulus into strain square. So this will be half into the Young's modulus 7 to 10 power 10 into strain that is 0.04 by 100 its whole square. Which will be 2 3 is 6, 2 5 is 10. So 3.5 into 10 power 10 into this will be 4 500. This is 4 into 10 power minus 4 whole square. 3.5 into 10 power 10 into 4 for the 16 into 10 power minus 8. This 16 5s 80. Five is 80. 16 3s are 48. 48 plus 8, that is 56. 56 into 10 power 2. So it is 5.6 into 10 power 3. Since it is 5,600 joule per meter cube. Option A is the correct answer. So it is told when you squeeze one end of a tube to get toothpaste out from the other end, Pascal principle is observed. It is true. So the assertion is true. Since we apply pressure at one end, so the same pressure is obtained at the other end also. Then change in the pressure applied to an enclosed incompressible fluid is transmitted undiminished to every portion of the fluid and the walls of the container. So it is the correct explanation also. So both A and R are correct, and R is the correct explanation of A. So option D is the correct answer. Here it is told a small ball of mass m and density rho, small ball of mass m and density rho is dropped in a viscous liquid of density rho naught. After some time, the ball falls with a constant velocity. What is the viscous force on the ball? Small ball of mass m and density rho is dropped in a viscous liquid of density rho naught. The density is naught. After some time, the ball slowly falls with a constant velocity. What is the viscous force on the ball? So the viscous force on the ball, viscous force, that is obviously 6 pi eta rb. 6 pi eta rb. Now viscous force plus the buoyancy force, that will be equal to the mg. So viscous force will be equal to mg minus the buoyancy force, which is mg minus the weight of the liquid that is displaced, that is v to rho naught into g. Now v will be equal to mass by density. This is mg minus mg into rho naught by rho, which is mg into 1 minus rho by rho naught by rho. So this is the required viscous force, mg into 1 minus rho naught by rho. So option A is the correct answer. And here it is told the Young's modulus for steel wire of length 6 meter and cross-sectional area 3 millimeter square is 2 into 10 power 10 Newton per meter square. The Young's modulus on steel wire is there. Of length L, which is 6 meter, and the area of cross section, that is 3 millimeter square. The Young's modulus is 2 into 10 power 10 power 11 Newton per meter square. Wire is suspended from its support on a given planet. A block of mass 4 kg is attached to the free end of the wire. block of mass 4 kg is attached to the free end of the wire. Wire is suspended from its support on a given planet. A block of mass 4 kg is attached to the wire is attached to the free attached at one end. From its support, and a block of 4 kg mass is suspended from its free end. Acceleration due to gravity on the planet G dash, that is 1/4 of its value on the Earth. The elongation of the wire is, so the delta L, the elongation of the wire, that is how much? G into 10, so G dash will be 10 by 4, that is 2.5. Therefore, the tension force, that is equal to mg dash. Therefore, the elongation, so the tension force, that will be equal to ya by L into delta L. The delta L, that will be equal to the tension mg dash into L into L. Length of the wire, that is 6 meter by AY. Area of cross section is 3 millimeter square, so 3 into 10 power minus 6 meter square into Y. Y is 2 into 10 power 11. Therefore, delta L, that will be 3 minus 6. So this is M is 4 kg. G dash will be 2.5 into, so be 10 power 6 minus 11. This will be 4 into 2.5, that is 10 to 10 power minus 5. So this will be 10 power minus 4 meter. 10 power minus 4 meter means 0.1 millimeter. So 0.1 millimeter is the elongation of the wire. Option C is the correct answer. And here it is told the average kinetic energy of a molecule of the gas is, average kinetic energy of a molecule of the gas, average kinetic energy, that is equal to, we know that, so it is e power 3 RT, 3 RT by M. No, it is the VRMS. So the average kinetic energy, that is 3, is half M to V square, that is 3 RT by M, is equal to 3 by 2 RT. 3 by 2 RT. So it is that is independent of the nature of the gas, and it is proportional to the absolute temperature here. Since average kinetic energy, as you can see, that is directly proportional to the absolute temperature of that gas. So option C is the correct answer. When it is told mercury drop is there, uh, mercury drop of radius 10 power minus 3 meter is broken into 125 equal size droplets. So this, let's call it, the radius is capital R. Given to its 125 equal droplets, surface tension of mercury is that is 0.45 Newton per meter. Then the gain in surface energy is, the gain in surface energy equal to surface tension into gain in surface area. Therefore, now gain in the surface area, that is equal to the final surface area of all the droplets minus the initial surface area of the large mercury drop. This will be 125 equal droplets, so 125 into pi r square, and then this will be pi r square. So now the volume will remain conserved, since by the mass is remaining conserved and the density of mercury will remain constant. So since mass is always conserved, so here since density is also same, so the volume should be same. The initial volume should be same as the final volume. So initial volume is 4 by 3 pi r cube, and final volume is 125 into 4 by 3 pi small r cube. So then 4 by 3 pi 4 by 3 pi will cancel. So r cube, that will be equal to 5r whole cube. Therefore r is equal to 5r. Therefore, so r is equal to 5r. Therefore, the gain in the surface area, that will be equal to 125 into pi r square. One 25 into pi r square minus this is pi capital R square, which is pi into 5r whole square, which is 25 pi r square. So it will be 100 pi r square. 100 pi r square is the increase in the surface area. So in the surface area, so the r, small r, that will be equal to r by 5, which is 10 to the 10, 0.2 into 10 power minus 3. R by 5, that is 10 power minus 4 it will be. That is 10 power minus 3. It is 2 into 10 power minus 4. So therefore, the gain in the surface energy, that is S, that is 0.45 into delta A, which is 100 pi r square, 100 into 3.14 to r square. R square is 2 into 10 power minus 4 whole square. So this much joule it will come. So this will be 45 into 3.14 into this is 4 into 10 power minus 8 joule. So this will be, okay, 4 5 so 20 for position, so it is 180 into 3.14 into 10 power minus 8 joule. So this will be, I can say 1.8, or I can say this is 0.18 into 3.14 into 10 power 3. So 10 power 3 minus 8, that is 10 power minus 5 joules. This will be 3 at 24. So this will be actually 5. So 5 into sorry, it will be 120 into 4 pi r square. And initial area that will be 4 pi r square since it is a spherical drop. So it will be 4 pi r square. So this into 4 it will come. It is 400 pi r square. It will be 400. So into 4 is also there. To 4 also. So it is approximately like this is 5 fourths. This is 0.2, so 0.6. So 2 into 10 power minus 5 joule approximately. Say 2.26 also approximately. So it is 18 for the 72. So 0.72 into 3.14. This will be approximately, I can take 3 to the 6, 3 7 are 21, 2.16 or approximately 2.26. 10 power minus 5 joule. So option D is the correct answer. Then it is told for a solid rod, the Young's modulus of elasticity is for a solid rod, the Young's modulus of elasticity is 3.2 into 10 power 11 Newton per meter square, and the density is 8 into 10 power 3 kg per meter cube. And the velocity of the longitudinal wave in the rod will So the velocity of the longitudinal wave is given as root over gamma uh, root over y by rho. That will be root over y by rho, which is root over y, that is 3.2 into 10 power 11 divided by 8 into 10 power 3 this much meter per second. So it will be 8 4 the 32 0.4 root over 0.4 into 10 power 8 11 minus 3 is 8 meter per second. So now this will be 0.4 means you can say that it is square root of 0.4 into 10 power 4, or you can write it, this would be root over 40 into 10 power 6 meter per second. So this will be approximately root over 40 is approximately 6 point something, 6.3, I can say 6.3 into 10 power 3 meter per second. So option B is the correct answer. And here it is told under the same load where A is there, having a length 5 meter and area of cross section that is 2.5 into 10 power minus 5 meter square, stretches uniformly by the same amount as another where of length 6 meter. Where A having length 5 meter and cross section 2.5 into 10 power minus 5 meter square, stretches uniformly by the same amount as another where B of length 6 meter. 6 meter is the length, and area of cross section A2, that is 3 into 10 power minus 5 meter square. The ratio of the Young's modulus of the where A to that of the where B, that would be how much? So Young's modulus. So here it is told it stretches by the same amount. This also stretches by delta. This also stretches by delta L. By A, that will be equal to F. So under the same load, so F is same, load is same. So if L1 by A1 delta L, YB will be F L2 by A2 delta L. Since F and delta L are same, so YA by YB, that will be equal to F L1 by A1 delta L divided by F L2 by A2 delta L. Now delta L will cancel, F will cancel. So this will be L1, this will be equal to L1 by A1 into A2 by L2. That means this will be L1 A2 by A1 L2. So therefore, YA by YB equal to L1. L1, that is 5 meter into A2, that is 3 into 10 power minus 5 divided by A1, that is 2.5 into 10 power minus 5 into L2. L2, that is 6. So 10 power minus 5 will get cancelled. So 3 to the 6, so 2.5 into 2 is 5. And 5 will cancel. So that is equal to 1. So 1:1 is the answer. Option C is the correct answer. And here it is told that if 1,000 droplets of water of tension, surface tension is, that is 0.07 Newton per meter, having same radius R, that is 1 millimeter each. They will combine to form a single drop. In the process, the release surface energy will come. So the release surface energy, that will be equal to the surface tension into the change in the surface area. Therefore, here the decrease in the surface area, that is your delta A, that is equal to, so it is the initial surface area minus the final surface area. Since here the decrease we have to find, if increase we have to find, then we would have found final area minus initial area, but here we have to find the decrease. So initial area minus final area. Initial area, that is initial area, that is 1,000, so 10 power 3 into 4 by R square minus the final area, that is 4 pi into capital R square. Now here we can say that we have to conserve the volume since mass is conserved and the density is same. So 4 by 3 pi R cube, that is equal to 1,000 10 power 3 into 4 by 3 pi small r cube. 4 by 3 pi 4 by 3 pi will cancel, so R will be equal to 10 R if you take the cube root on both sides. So R is equal to 10 R, so this will be 1,000 10 power 3 into 4 pi R square minus this will be 4 pi into 100, means 10 power 2 into R square. So this will be 1,000 minus 100. 1,000 minus 100, that is 900 into 4 pi R square. This one. So therefore, the release in the surface energy, that is 0.07 into 4 pi 4 into 22 by 7 to pi R square. R square. R is 1 millimeter. So R I can write 10 power minus 3 meter also. This will be 10 power minus 3 whole square. So this much joule it will come. 7 and this will cancel 0.01. So this is 44 4 into 22, that is 88. That will be 0.88 into 10 power minus 6 joule, or I can say this will be 8.8 into 10 power minus S, that is Newton per meter. Radius is okay. Okay, into 900 also have to do. S into delta A, which is 4 pi R square into 900. So this into 900 also have to do. This into 900 means 10 power This will be actually 0. Okay, this we got. Therefore, the change in surface energy, that is the release in surface energy, that is 0.88 into 900 into 10 power minus 6. This will be 9 is 72, 9 is 72, 7.92 into 10 power minus 4 joules. 7.92 into 10 power minus 4 joules. So option A is the correct answer. A force is applied to a steel wire A. Force is applied to a steel wire A, which is rigidly clamped at one end. As a result, elongation, that is delta L in the wire, that is 0.2 millimeter. If same force is applied to another wire B, same force is applied to another wire B, same force is same, of double the length. So its length is 2L, and its length is 2L, and it's the length of where A is L, and diameter 2.4 times that of the wire A. So if the radius is R, then its radius will be 2.4 R. Since the diameter is 2.4 times, means the radius also will be 2.4 times that of the wire A. The elongation in the wire B will be how much? How much will be the elongation in the wire B? Delta L B will be how much? It is told that wires having uniform circular cross sections. So they are cylindrical wires. So here delta L I can say that is FL by AY. Delta L is FL by AY. Young's modulus of steel. So the Young's modulus will be same since both the wires A and B are made up of steel only. So FL by AY. So that delta L, so this will be FL by pi R square into Y, and that value is given as 0.2 millimeter. So therefore, now the delta L B, which is the elongation in wire B, that will be F L, that is 2L by A, that is pi into 2.4 R square into Y. So this will be FL by pi R square Y into 2 by 2.4 square, which is equal to 2 by 2.4 square times of this delta L of the wire A. So therefore, the elongation in the wire B, that is 2 by 2.4 into 2.4 into 0.2 millimeter. So it is 2, 1.2, which we can cancel. We can, so 2, 6, 12 is 1 by 6 into 2.4 millimeter, which is approximately 1 by 6 4s are 24. So 12, 1, 4, so 14.4. So 1 by 14.4 millimeter. 14,684. It will be 1 divided by 14.4. So that is approximately 0.0694 millimeter, which I can say approximately this is, I can write 6.944 into 10 power minus 2 millimeter. Option A is the correct answer. Then it is told the height of a liquid column raised in a capillary tube of certain radius the height of a liquid column, raised in a capillary tube of certain radius r, the height we have to find what height it will rise. The height that is given as 2t cos theta by rho gr. Now, certain radius when dipped in a liquid A, so liquid A vertically is 5 centimeters. So height raised is 5 centimeters. If the tube is dipped in a similar manner in another liquid B of surface tension and density, double the values of delay. So this h, which is 5 centimeter, that is 2 into s into cos theta. Let's call the surface tension as s into cos theta by rho g r. Surface tension and density will be double. Raised in liquid B. Okay, so S is also being doubled and density is doubled. So S dash should be 2s dash cos theta by rho dash gr. Since the radius is kept same, since same tube has been dipped, so the radius will be same. So S dash is 2s cos theta and rho dash is 2 rho gr. So 2 will get cancelled, so it will be equal to 8. So the same height it will achieve. So the height of the liquid column raised will be same. So that is 5 centimeter only. So now 5 centimeter is 0.05 meter. So option A is the correct answer. Here it is told choose the correct relationship in between uh, Poisson's ratio, bulk modulus, and modulus of rigidity of a given solid object. So we know that Poisson's ratio it is equal to the lateral strain, that is delta r by r by longitudinal strain minus of that, which is lateral strain by longitudinal strain, and bulk modulus that is given as the minus delta v by v, and modulus of rigidity is the shear modulus that is equal to phi, that is equal to x by L. So the rule is actually 2 eta into, the rule is 2 eta to 1 plus sigma, that is equal to, okay, 2 eta into 1 plus sigma is equal to 3k into 1 minus 2 sigma. So if we rearrange it, then we get that 1 plus, okay, 2 eta plus 2 eta sigma equal to 3k minus 6k sigma. So I can say that 6k sigma plus 2 eta sigma, that is equal to 3k minus 2 eta. So therefore, I can say sigma is equal to 3k minus 2 eta divided by 6k plus 2 eta. So option B is the correct answer. Then here it is told a fully loaded Boeing aircraft has mass. So a fully loaded this Boeing aircraft, its mass is 5.4 into 10 power 5 kg. Its total wing area, that is 500 meters square. It is in level flight with a speed of 1080 kilometers per hour. Is the density of the air that is given as 1.2 kg per meter cube. The fractional increase in the speed of the air on the upper surface of the wing relative to the uh, lower surface in percentage will be. So if the speed of the air on the upper surface is slightly higher, that is suppose V2, and in the lower surface the speed is V1. So increase in the speed of the air on the upper surface. So V2 is obviously more than V1. Now increase in the speed, so V2 minus V1 relative to the lower surface. So V2 minus V1 by V1 into 100%. So that will give you the 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 fractional increase in percentage, the fractional increase in the speed of the air, speed of the air on the upper surface of the wing, the upper surface of the wing relative to the lower surface in percentage. This will be V2 minus V1. This will be V2 by V1 minus V1 into 100%. So that will be V2, that is so 1080 kilometer per hour. That will be equal to in meter per second. That is 1080 into 5 by 18. So 9 to the 18, 12 9 is 108, 2 6 are 12, which is 300 meter per second. So if we say that V1 that is 300 meter per second and V2 that will be 300 plus something plus delta V seconds. So this delta V, you have to find delta V by V1 into 100%. Okay. So let's say this delta V by V1 that we have to find out first. Now, you know that half, that is the pressure difference, the force is equal the dynamic lift force upwards, F, that will be equal to mg. M is the mass of the aeroplane, and that is equal to the pressure difference, that is P1 minus P2 into area of the wingspan. And P1 minus P2, P1 minus P2, by using the Bernoulli's principle, I can say that is half into rho into V2 square minus V1 square, which is equal to half rho into V2 minus V1 into V2 plus V1. So this I can say it is approximately half into rho into delta V into 2V, 2V1 approximately. So 2 will cancel, which is approximately rho delta V into V1. Now therefore this rho delta V into V1 into area of the wingspan, that is equal to mg. Therefore now delta V by V1 I have to find out. So we can divide both sides by V1 square, 1 square. So this will be rho delta V1, delta V by V1 into A, that is equal to mg by V1 square. That means that delta V by V1, that is equal to mg by rho A into V1 square. Now we have to express this in percentage, so that into 100%. So this will be mg by rho A V1 square into 100%. Now mg, m mass of the aircraft, that is 5.4 into 10 power 5 into g. G is 10 divided by g square divided by rho 1.2 into A, that is 500 mg by rho A m into g by rho A to V1 square to 300 into 300. So 1 square 200, this much percentage. This will be 100, 100 that will cancel out. Then 0, 10 power 6, 0, 0 I can cancel. This will be 5.4. So this is 54000 5 5, and then by 1.2 and 5 is 60. So this is 600. 600 into 30. So 0, 0, 3 zeros I can cancel out. 3 6 are 18. 18 3 are 54. So 30. So this is 30%. Percentage increase in the speed. Okay, sorry. It's wrong. So this is actually 5400,345 divided by 60. So 600 into 30 into 3, that is 90. So 0, 0, 0, 0 will cancel, 3 zeros will cancel, and 6 nines is 54. So 10. So 10%. So 10% is the fraction increase in the speed of the air. So it means the speed of the air on the upper surface of the aircraft will be 10% higher than the speed on the lower surface of the aircraft. So option D is the correct answer. And here it is told surface tension of a soap bubble S, that is 2 into 10 power minus 2 Newton per meter, and work done to increase the radius of the soap uh, bubble from 3.5 centimeter to 4 centimeter to 7 centimeter will be. The work done will be the surface tension into the increase in the surface area. The surface tension is 2 into 10 power minus 2, and increase in the surface area means final surface area minus initial surface area is 2 into 10 power minus 2, and those final surface area is 4 pi r square, 4 pi into 7 square, but it is given in centimeter, so we have to convert into meter also. 4 pi r square, 7 into 10 power minus 2 whole square minus 4 pi into 3.5 into 10 power minus 2 whole square. So this will be 4 pi, I can take as common out. So 4 pi into 10 power there. This is 8 pi into 10 power minus 2. Eight pi into 10 power minus 2. This will be 49 into 10 power minus 4. Minus this will be 49 by 4 into 10 power minus 4. So 8 into 22 by 7 into 10 power minus 2 into 49 into 10 power minus 4 into this will be 1 minus 1 by 4, that is 3 by 4. 7 sevens are 49. 4 to the 8. So this will be 44 into 7 3 are 21. 21 to 10 power minus 6. 44 into 21. The 4 ones are 4 to the 8. 84. 4 12 924. So 924 into 10 power minus 6. It's not joule. So I can say it is 9.24 into 10 power minus 4 joule. Option D is the correct answer. It is told a bicycle a bicycle tire is there. So that is filled with air, having a pressure, that is the inside pressure, that is 270 kilo Pascal, means it is 270 into 10 power 3 Pascal at 2 and at 27 degrees Celsius. The approximate pressure of air in the tire when the temperature increases to 36 degrees Celsius is. So the volume will not change. So I can say the volume is constant. So PV, you know that PV by T is constant. It means that when volume is constant, I can say P is directly proportional to T. That means P1 by T1 is equal to P2 by T2. So the pressure is 270 into 10 power 3 Pascal. When the temperature is 27 degrees Celsius, means it is 300 Kelvin. 27 plus 273, that is 300 telling. That will be equal to P2 by T2, that is 270 plus 36, that is 306. 306. So now P2 that will be equal to 306 by 300 to 2.7 into 10 power 5 Pascal. So that will be 100.02, 1.02 into 2.7 into 10 power 5 Pascal. Means I can say it is 102 into 2.7 kilopascal. So it is 2.7 and 202. It's slightly higher than 270 obviously. 278 approx 27 twos of 54. 7 0. That is another 27. So 275.4, 75.4 kilopascal, which is approximately 276 or 278 approximately, I can tell. So option D is the correct answer. So here surface tension will have the unit. So we have to match with the units. Now pressure will have the unit. Pressure is force by area. So it is MLT is kg meter per second square by meter square. So that is kg per meter per second square. So pressure will be 3. So B will be 3. B will be 3 obviously. So now A and B have to choose. So C I can check. So D also I can check. That is impulse. Impulse is change in momentum. It is delta change in momentum, which means m delta v. So mass into velocity, which is kg meter per second. So impulse. So D is 2. D is 3. D is 2. So obviously option A is the correct answer. And also we can check that A will be 4 only, since surface tension, that is force by length, which is kg per second square. And viscosity eta, that is eta, we know that is 6 by eta RV, eta force by RV, length into the velocity, which is kg meter per second square by meter square per second. So which means it is kg per meter per second. Option 1. So C will match with 1, A will match with 4. So option A is the correct answer.